Bem, boa noite. Voltamos com a segunda parte das apresentações do colóquio dessa noite. Então, agora nós teremos a palestra da professora Vitória Lemieux. Professora Vitória Lemieux, ela é professora de ciência arquivística na Escola de Informação da Universidade da Colúmbia Britânica e fundadora e co-líder do Centro de Pesquisa Blockchain at UBC, que é um núcleo multidisciplinar de pesquisa e educação da Universidade sobre Tecnologias Blockchain. Seus interesses de pesquisa incluem os riscos à disponibilidade de registros confiáveis, em particular na interseção entre sistemas de manutenção de registros em blockchain, inteligência artificial, privacidade e segurança, e como que esses riscos impactam a transparência, a estabilidade financeira, a responsabilidade pública e os direitos humanos. A professora Lemieux já recebeu diversos prêmios por suas pesquisas e contribuições nas áreas de arquivos, gestão de registros, tecnologia blockchain e segurança cibernética. Portanto, good night. Professor Vitória Lemieux, please. Are you here? Então, vamos aguardar um pouquinho a professora Vitória Lemieux entrar, para poder colocar a apresentação dela. A apresentação dela é a respeito do Clio-X, né, que seria uma solução, uma plataforma, né, blockchain, voltada para registros, né, no caso, né, no Brasil comumente falado como arquivos, né, e ela vai nos apresentar essa solução que já está, né, disponível, que já está na internet, né, então a gente já pode, inclusive, acessar. Né? Então, vamos só aguardar um pouquinho para que ela possa entrar. Né? Um momentinho. Hi.
Hello.
We have some technical problems.
I'm not.
Okay.
I'm not hearing you, Claudio.
No? No? Well, I'm using my microphone. Wait a minute. Okay? Okay? You listen me?
I will come back.
Are you listening me? Okay. Desculpem os problemas técnicos. Estamos aguardando a professora Vitória. Ela está entrando.
Hello.
Hi.
I can hear you now.
Okay. So we are now online in YouTube. So I will make a little presentation about you.
Thank you.
And later you can start your speech. So okay. I will talk in Português now, ok? So, então, boa noite a todos novamente. Né? Retomando, a professora Vitória Lemieux, ela é a professora de ciência arquivística na Escola de Informação da Universidade da Colúmbia Britânica, UBC. É fundadora e líder da Blockchain at UBC, núcleo multidisciplinar de pesquisa e educação da Universidade sobre as Tecnologias Blockchain. Seus interesses de pesquisa incluem os riscos, a disponibilidade de registros confiáveis, né, em particular na interseção entre sistemas de manutenção de registros em blockchain, inteligência artificial, privacidade e segurança, e como que esses riscos impactam a transparência, a estabilidade financeira, a responsabilidade pública e os direitos humanos. A professora Lemieux recebeu diversos prêmios por suas pesquisas e contribuições nas áreas de arquivos, gestão de registros, tecnologia blockchain e segurança cibernética. Então, seja bem-vinda, professora Vitória Lemieux, and now you can start your presentation. Thank you very much.
Okay, muy obrigado. I will speak in English, if that's okay. And may I share my screen? I would like to share my entire screen, and then I can toggle between the presentation and can you see the presentation? Please let me know.
Not yet. Just, yeah, now we can see.
Now? Okay, good. Okay, thank you very much. So I will be presenting research that is focused on our project Clio-X, a cultural heritage and archives ecosystem. So let me tell you a little bit about how this research came about, this research project came about. It is one outcome of the Inter Pares Trust AI, which is led by Professor Emerita Luciana Duranti, my colleague at the University of British Columbia, and Dr. Mohammed Abdul Magid. So under that research project, we had a project that was focused on privacy. And we were looking at artificial intelligence for sensitivity review to identify sensitive information in archival, corpora of archival documents. And then I started to think about applying privacy-enhancing technology. At the same time, I lead the blockchain research group at the University of British Columbia, blockchain at UBC. And I had been doing research into Web3 technologies for protection of data. So this research, this project, is the combined outcome of both of those research efforts. So here is our team. We have a team of students that you can see from the University of British Columbia, led by myself with input from my colleague at blockchain at UBC, Dr. David Wang. But also we have colleagues in Spain at the University of Lleida. University of Lleida is just outside of Barcelona. And also the Spanish distance university, UNED, which is headquartered in Madrid. So that is our research team. And so we started off being motivated by this question of how can we protect the privacy of sensitive records but still make them available to researchers. So that was the initial motivating question. And we wrote an initial paper. This was with a former student of mine, John Werner, looking at how could we apply privacy-enhancing technologies to enable access to researchers to access archival records, even when those records are still under access restrictions of some sort. And so this area of privacy-enhancing technologies allows computation specifically in the form of artificial intelligence to compute over even protected data. So this is a whole class of emerging technologies that uses cryptography, uses privacy-preserving federated machine learning, uses differential privacy, trusted execution environments, a whole suite of different technologies that protect privacy but allow for computation over the data. So this is the initial paper. And then we started to have the concept of building this ecosystem, this infrastructure that embedded privacy enhancing technology to create a privacy-preserving compute infrastructure for archives. And we first proposed that 2 years ago, about the same time as we're talking now. So 2 years ago, we started to build Clio-X, which is what I'm going to present to you today. But in the process of building Clio-X and talking to archivists, we came to understand that archives are increasingly using AI, but there are a wider range of ethical concerns about AI that go beyond just privacy. So we started to talk to archivists about what were the wider concerns, and this graphic here shows you some of them. But at a recent conference that we presented at in the United Kingdom, we asked archivists, what were they thinking about? What are they concerned with? And this follows on with a number of focus groups that we've had as we've designed Clio-X. So the images may be a bit blurry. I hope you can read it, but archivists are concerned with the authenticity of data. And I think that a question about that came up in relation to our previous presentation about images. They're also frustrated because initial trials with artificial intelligence have been quite mixed. There's a lot of positivity, a lot of hype, as it's sometimes called, but a reluctance to explain methods and sources of errors. And they are concerned, and this is motivating my initial research, was they're concerned about where the data is going to reappear. So they're concerned about loss and control of that data. They're concerned about security breaches around data. They are concerned about the environmental implications of using AI as well. Energy consumption, water consumption, increasing global conflicts. They're concerned also about losing creative influence. This also came up in our previous presentation with scholars saying, well, if we're using AI, we're using these computational techniques, where's the scholarship in that? And they're also concerned about not understanding about what is happening, what's going on behind the scenes, if bias is being introduced, if misinformation is being introduced without their knowledge. And of course, data privacy, as we started with, also inaccurate data, maybe data hallucinations or hallucinations generated by AI. And so, there's a wide range of concerns. These are some more the things about AI what data is AI being trained on, chipping away at integrity and trustworthiness. Bias from the programmer, a lot on the environment, loss of jobs is another one that we haven't mentioned already. Big tech taking over. So, so much dominance by the big tech companies and situated in Silicon Valley and control. So these are the kinds of concerns that archivists have expressed. This is a particular these themes that we gathered at this recent UK conference, the Archives and Records Association of the UK, mirror and amplify what we've been hearing as we've been doing the research on the development of Clio-X. So these are the problems that we've been trying to solve as we've been thinking about how do we design this infrastructure. So this infrastructure, Clio-X, is meant to help researchers explore archival data securely and to help archives make their archival data available securely and to build knowledge collectively. So it is meant to be a privacy-first platform built by and for researchers, archivists, and cultural institutions to help them explore, share, and collaborate on sensitive archival material, but not strictly. We also now, we're focused on sensitive archival material initially, but it is just now any archival material, again, without compromising on privacy and data sovereignty or ownership. So that's what Clio-X is designed to do. So we have a video I won't show you, but if you go to our Clio-X site, which I can give you the site address, the portal address, after this you can watch the video. But what we basically explain in the video is how this ecosystem, the architecture is different from the traditional types of systems that we've become accustomed to. So first of all, it's decentralized. And that's where Web3 and blockchain comes in. So what does that mean from a practical standpoint? It means that for each archives, for each custodian of data, the data does not have to be uploaded into our platform to make it available. That is not necessary. Instead, what archives do is they expose the location where the data can be found. That gets published to the platform, but not in an open way that anybody can access it. When it's published, and I'll demonstrate this, it is encrypted. And it's encrypted using a form of cryptography called zero-knowledge proof cryptography. And that's a type of cryptography that allows you to prove that you know something like a password without revealing what that password is. So in the same way, the system can prove that it knows how to access the location of your data without revealing the actual location of your data. So only you know the actual location of your data, but through the use of zero-knowledge proof cryptography, Clio-X can orchestrate an AI to access that. And when the data is accessed, it isn't accessed, the AI doesn't go into your repository and gain access to your repository. Instead, like the image you see here, the AI, the data is temporarily replicated to a virtual trusted execution environment, like these pods here, a virtual clean room or virtual secure space where the AI enters in and your data enters in only as long as needed to complete the compute job. And this secure pod or space doesn't allow anything else to enter in but your data and the AI, and it doesn't allow anything else to leave that space except for the output of the compute job. So this means that your data, it remains under your control, and the AI has access to it, but only under these very restricted conditions. And the output of the data is also controlled. So as I mentioned, these secure pods where the data is momentarily united with the artificial intelligence to complete a compute job, this happens in a trusted execution environment. And this allows for a very secure, these are also decentralized. So there are a number of these trusted execution environments. It's not always the same one. And this is also managed by cryptography. And so this means that the trusted execution environment is quite secure, and it can be created and taken down as needed. In addition to decentralization, compute to data framework, trusted execution environments, we're also using privacy preserving machine learning where it's needed, where we know that the data has sensitive or personally identifiable information in it. So what we're doing here is part of the algorithm would identify sensitive content using natural language processing, named entity recognition, and it would mask out. So it would mask out names, identity numbers, and other content that is deemed to be sensitive, for example. So we've experimented with this with a set of emails. We're just experimenting with public information. So the Enron emails are a publicly available data set, but it simulates the kind of sensitive information that you could find typically in an archives that has a file that contains emails. And the other technique that we're using is also that when the compute job is completed, the output of the compute job doesn't give you access to the raw archival data. So for example, you don't see the Enron emails. What you see is a sentiment classification or something that allows you to do a visualization of that data. So the researcher still has, even though the data is sensitive and is being made available to them, they don't have access to the raw data, but they can still detect large-scale patterns. And this can help historical researchers, for example, analyze these sensitive data sets and look for patterns across large corpora of data. So it's a technique in the digital humanities called distant reading that relies on data visualization. And you'll see we've also implemented chatbot capabilities. And so when we compute the data for a chatbot, again, at the moment, we're just providing access to open data sets, but we can also run the privacy-preserving federated machine learning to mask out what data is made available to the chatbot. So that is on our technical roadmap. Okay, so this is a Web3 application. So it does run on a blockchain. So the first thing that you need to do is you need to set up a wallet that would allow you to interact with the blockchain and to receive tokens. And the tokens are not necessarily the tokens of the underlying blockchain that we use. We use a privacy-preserving blockchain called Oasis blockchain. But the tokens are actually denominated in an experimental digital euro. And so maybe now what I can do is I can move over here to bring up. Are you now able to see the same landing page here? But if I move to catalog, can you see sort of a set of records here that says 777 results? I just want to make sure you're seeing my screen. Claudio,
Yes,
can you?
yes,
Yeah.
yes.
Okay, good. All right, let me
can
go
see.
back. Good. So this is the actual portal. So if you want to actually look at our portal, you can just type in Clio-X.org and it will bring up the actual portal. But it is a permissioned blockchain, so it's not open to everyone. You do have to register for use first. And so you will see here, we have 3 main rules. So the archivist, here's where you can sign up, and it'll walk you through the sign up process. But the archivist also is the one who would be more than likely to publishing data, although some archivists would also be wanting to publish specific algorithms as well. So there's an option to do that too. Researchers are looking for data. They're looking for algorithms that they want to use to conduct their historical research. And the ecosystem partner is really about how we govern this community collectively. So our philosophy is that, as I mentioned at the beginning, that this should be infrastructure that is made for archivists and researchers by archivists and researchers. And so the governance should also be by archivists and researchers. Okay, so the first thing that I might want to, the first thing to note is that there's a catalog. In the catalog, we can see all the different data sets that are available here, and we can choose data sets, we can choose algorithms, but I'll come back to that because the first thing I want to show you is how would we actually make our data available on this platform as archives. So as I said, you can publish a data set, you can publish an algorithm, you can publish even software as a service. So our previous speaker mentioned that there's an app that is available for image processing. That app, for example, could be made available through this platform. Right now, we're just going to focus on a data set. So I'll just call this test 5, and I'm just going to call it, Vicky's test 5. And we do want to be able to set up a capability to import from your archival catalog, your descriptive systems, but that is on our technical roadmap still. So for now, it's just a very basic information. I'll skip over service credential for now. Just put in tags, would be email, test, etc. Whatever descriptive tags you want. Now, one of the things that we allow for in the platform is to indicate whether it contains personally identifiable information. So here you can identify the name of the data controller, who the data controller is, so the name of your archives. And then you can indicate the legal basis. So for example, it could be, if you're in the EU, it could be the General Data Protection Regulations. I'm in Canada, so in British Columbia, so it's our privacy regulations called PIPEDA, and of course, you would have your own applicable privacy regulations wherever you are. Here you can indicate the purpose for which the data can be used, and the name of the data protection contact point, and also the name of the person to contact if you want to withdraw consent for the use of the data. So this is all relevant to protecting the data and making sure that when an individual researcher is going to interact with this data, they're aware that it contains personally identifiable information, and also it can be used to restrict what kinds of algorithms are going to be able to process that data. So as the person who is publishing data, you have to agree to the terms and conditions of the portal. We have all of our terms and conditions indicated, including our own privacy policy. So you can look at that. I would then press continue. Now you're given 2 options here. You can either allow researchers to download data. So that's not prevented on the platform, but really what we're more interested in terms of protecting data sovereignty and privacy is just allowing researchers to compute over the data in this controlled way that I've described. So the data pods or trusted execution environment in the system are called the access controller. And here, I'm using a particular access controller here. This access controller actually is located in Germany. I could use a Canadian access controller. I could use a Spanish access controller. I could set up a Brazilian access controller, and have that be located in particular states. This also helps protect data sovereignty, because if I'm concerned that I don't want my data processed outside of my state or my country, then I can set up my own access controller that is situated in the locality that I know retains the sovereignty of my data. So in this case, I'm not really concerned. It's just experimenting. So I can use whatever processor is available. So this is the one that's available. And then here, this is where I make the location of my data. I publish the location of my data. Remember, I publish the location, but it gets encrypted, so nobody sees this. So I'm just going to put this location in. It has to be validated, so the solution Clio-X has to know that it can access the data for processing purposes. And so yes, here it's been validated. So I could also upload a sample file if I wanted to have a version of the data, smaller sample that gave researchers an idea of like, what do these files actually look like in their raw form? Obviously, if it contains personally identifiable information, you'd want to make sure that that doesn't contain any of the sensitive information. So I won't talk about parameters for now, but I would continue at this point, and I would indicate how long I would like the data to be made available for. So you can say like permanently, which you can always remove it later. There are techniques for doing that, even if you've indicated, permanent availability. But you can also specify that, okay, I have a researcher coming in. I want to give them access to this particular data set when they're here. And so you could also say just for one day. And you can also indicate what is their wallet address. So you can have an allow list. You can also deny certain wallets. So there's a lot of different access controls that you can set up in this system. So I'm just going to leave it at blank for now. You can also indicate your licensing terms. This is probably more relevant for software or algorithms where there might be an MIT license or Creative Commons license, open source. And then you can, for the archives for your data, if, for example, your data has particular restrictions, you can, for example, copyright restrictions. For example, you can create a URL, a file at a URL, and you can make available those terms and conditions here. And any researchers that are accessing your data have to agree to those terms and conditions before they can use the data. So here, the next thing I need to do is I need to indicate whether I'm going to make this data available for free or whether I'm going to offer it for a price. And this is one of the other really valuable things about about Clio-X for archives, because what we're finding is that many of these big AI solution providers, the ChatGPT, OpenAIs, the Googles, and so on, and large companies that have made a lot of money off of how they have gathered up and made available archival data have not, those funds and that money has not flowed back to archives in the same proportion. So, for example, Ancestry.com sold in 2020 for 4.2 billion, and they made a lot of money as a company. They do support a lot of archival conferences, but I think that a lot of archives would like to see that kind of value returned to them as well, especially in the era of AI, when we have valuable data. That data is so important to training AI models that is very valuable. So it's a way for us to get something back for allowing researchers or large companies and organizations more so that would be commercializing the output of processing our data. So you can put a price. For example, if I wanted to make my data available for 50 euros, I could do that. When we charge a price for the data, we see that there's a small portion that goes back to this larger Pontus X community that Clio-X is a part of. This marketplace fee is the Clio-X fee. At this point, we don't have one that we would hope to, and when we do collective governance, come to a reasonable understanding of what is a fair fee to offset the cost of the computing infrastructure that we're providing. And so the archives could potentially earn 49, like 50, almost 50 euro, because the fees are quite low. That would come back to your wallet. Of course, at this time, it's just experimental tokens, so it's not real euro, but we are moving towards that quite quickly. So you could earn, say, 50 euro for making your particular data set available. And the archives would set their own pricing standard, but as we're governing as a community, we can have conversations about what we do think is fair pricing and so on. But for now, we're just going to make it available for free, and we'll continue. So here now is my data set. And then what I would do is I would continue to actually order it. So what happens when I order it is I create the token. So the data location gets turned into an NFT. And it creates a unique identifier that is registered on the blockchain. And then that NFT or unique identifier is published to the catalog that you saw earlier. So if I submit this, we hope that I can confirm it, and I can actually, and I have to confirm it 3 times. So I'm really just submitting my private key from my wallet, and which is connected to a smart contract that is executing these processes on the blockchain. So it's running through all these processes. I guess I have to confirm a couple more times because there's 3 processes, 3 confirmations, and then hopefully at the end of that, it will be all ready to go. So yeah, so we've completed that now, and we can view our asset in the catalog. It takes a minute for it to come up, but we should be able to view the asset in the catalog by searching for it. And yes, indeed, here it is the one I just created here. You can see the unique identifier for it here. And if I want to create an authenticity check now, this is where I could prepare a service credential. So that's where the service credential comes in. Okay, so that's how I publish data. But let me change roles now. I'm going to play the role of the researcher, and I want to actually browse the catalog. I want to try and order a compute job as a researcher. So I'm going to, first of all, try with the Enron data set. And yeah, I think this might be the one. No, we've got a lot of test data sets here. So sometimes I forget which ones are the correct ones. I think it might be this one. Yeah, this is this one. Okay, so you can see here when I select a data set that I'm interested in, and of course, right now the descriptive data isn't so great because this is the development network that I'm showing you. But you can see this is where the trusted data execution environment is. This one that we're using in Germany for this particular example. And here's the list of algorithms that are allowed to compute over this data. So the one that I'm interested in is this Clio-X demo algo that's going to do sentiment classification. So you can see here that I have to agree to the terms and conditions. I also have to acknowledge the custom terms and conditions and the license arrangements that have been set up in connection with the data that I'm using. So I acknowledge that here. I won't click on the custom terms and conditions in the interest of time. But once I've agreed to the terms and conditions, I can order my compute job. So it runs exactly the same way, where I'm confirming a smart contract transaction that is executing on the blockchain. And it'll take a minute, for it to run the computation process and finish ordering, because it's ordering the data, it's ordering the algorithm, and then it'll order the computing infrastructure. It'll set up the trusted execution environment. So that all has to take place. Once that takes place, then it should confirm that my compute job is all set up and that my compute job is running. So just have to confirm one more time. Okay, so my compute job has been ordered here, and now I can see, that it is configuring. It's setting up my trusted execution environment, and as soon as that's configured, it will start running my compute job. So it takes a little while, maybe sometime, depending on the size of the data set and the complexity of the algorithm, it can take, and we're only using CPUs, we're not using GPUs. So maybe like 15 minutes, 30 minutes, depending on the data set, as I say. So what I'm going to do now is I'm going to say, okay, what happens after our compute job is finished? Okay, once the compute job is finished, there are certain things I can do with the data. So for the data that I've ordered, I can do visual analysis of the text. So I've preloaded, actually I haven't preloaded, hang on. Okay, yes, I have preloaded. So here I have, oops, maybe I have to, so it'll take a minute maybe to, so let me remove that, let me re-add it. So basically what I've got here is I've got all my finished compute jobs of relating to this Enron data. So if I want to then do visual analysis of this data, this is using that distant reading technique that I mentioned to you earlier. I have to add the data. I'll probably have to approve it 5 times because there are 5 visualizations. So it's just a kind of a boring process that I have to complete, but it is important for security because that means that if I ordered the data and pay for it with my digital euros, nobody else can kind of use the data that I've actually ordered. So here you can see now, once I do that, it loads it up into our Viz Hub. And I can see that I have several visualizations. So I can see the email distribution, for example. Here I've got a larger visualization, which I can expand. I can hover over certain things and yeah, let me just try and hover. Yeah, so you can see details when I do that. So that can give researchers a sense of like, what is the contour of this data set? And then because we've used the sentiment classifier, it's also sentiment classifying, and it's used a privacy preserving machine learning algorithm. So the sensitive content has been removed first, and then it classifies the remaining content to produce this sentiment classification. So we can see here, well, we have, some negative sentiment happening here in, April 2000, like what's that all about? So I can go down here and I can see, oh, this is positive, I should say positive sentiment. I can see here, oh, yes, these are the words that are driving the positive sentiment. So there was a lot of thanking going on, my thanks. So these are words that are driving that. And then if I want to look a little bit more closely, I can go again, I can come up here and hide the details. I can come up here and I can zone in using the slider on a particular date range. So if I'm interested in what's going on this April 2000, I can look at that more closely. And again, I can see words that are driving the sentiment. So that can help a researcher really understand, like what is the mood of this, of all of these emails. And, if I'm interested in like very controversial sort of topics, I might look for negative sentiment. If I'm looking for like really positive sentiment, it can help me to explore that. And then I can also look at word clouds to see specific words. So here's our word cloud visualization. And I have the option of, reducing the number of words, increasing it, maximum words to display. I can also edit stop word lists. So if I don't like, if I'm not interested in that word, please, I can add that to the stop word list. I can save that and I can recast it until I start to see meaningful patterns in the data. And then finally, we have a document summary, which just gives you an overview of the vocabulary density, the words, etc., the top words, and so on. So that's our data visualization use case for email. As I mentioned, we also have, we've developed a number of chatbots. We are working with the National Archives of Cameroon. We developed a chatbot assistant for them. We're working on an inter pares chatbot. And we also are working with the University of Lleida. And I'll just go in to demonstrate that. That chatbot, that is their historic budget data for their university. This is all open data. This is so it is public data, but we can interact with that public data with our chatbot. So here I can add more than one data set if I want to. So that's the other thing that we can do. We don't need to restrict ourselves to just one data set. I could add a presentation. I could add budget execution. I can have 2 different data sets that I'm adding to my chatbot, and it's what it's doing is it's adding a RAG, a retrieval augmented generation, a sort of knowledge base, graph database that is what the chatbot is going to interact with. So again, it's not interacting directly with the raw data. So that allows us to introduce privacy preserving elements when we need it. This is a public data collection, so we don't need it, but when we need it, we can do that. So then I can ask a question like, please, can you help me prepare, prepare a budget presentation on the university's budget 2020 to 2024. It's going to take a little while to upload the model. We're using right now, we're using a fairly small model. It's a Llama 3, OLAMA, so it's open source. It's a 2B model. That's a very lightweight model, but we still get pretty good results. And that model is running over a very restricted knowledge base that goes back only to the database, the output, the compute jobs output that we have specified should be loaded into this. And the reason we are doing that is because it helps reduce hallucinations of the AI. So depending on like the kind of question I ask, sometimes the AI will come back and will say, I'm sorry, I don't have the answer to that question in my knowledge base. That's actually a good thing. We don't want the AI making things up, because like just in a general like chat GPT, it might, if it doesn't have the answer, it might just make it up. It might hallucinate it and say, well, okay, the budget figures for 2020 were, this, and that's not correct. So here's the answer that we get. So according to the university's budget for 2023, the main growth areas, blah, blah, so it gives me a pretty good response to that. And this is again based on the knowledge base. And then I can continue to interact with it to get, more precise and better responses to, what I really want for this particular question that I have. So that's our chatbot, and we are working on privacy preserving. We're working on multilingual chatbot. Already we can handle English, French, Spanish, and Catalan, but we're working on other languages as well. And then it would be good to be able to have multimodal capabilities, which means that it could analyze not just text, but also images and maybe even sound recordings. So with that, I will go back to my slides here. So these are just static images of what I've just shown you. And I will just move on to the feedback that we've gotten so far when I've demonstrated this. So particularly, I've demonstrated it many, many times, but at this recent UK conference, this kind of highlights some of the things that we're really happy that archivists are seeing in the platform, that it's not just for bigger institutions. So one of the problems that we're seeing with AI is that the AI is capable for the larger institutions, very technical staff, well-trained staff, but for smaller archives, they're not going to have access to the training, the technical staff, or the technical infrastructure. But with Clio-X, they can, because they have their storage location for their digitized records or their digital records, and then they can just order computing on demand. So, and the algorithms have been designed by, could be designed by people all over the world with expertise. And so they don't need that heavy duty training. They don't need that heavy duty infrastructure. So that's really important, I think, to make sure that we provide equitable, fair, and equal access to the AI for all archives. And it's a collaborative approach to data analysis and decentralization. So, many archives can offer their data. Many archivists or other kinds of researchers can offer their algorithms and make these, or software, and make these available on the platform. It's very collaborative, and the governance is meant to be collaborative. Others have said that they really like that there's lots of steps to safeguard publication and use of data, which indeed there are, you would have seen. The ability to analyze the data is a good feature. So the visualization hub, the chatbot, and people have said the usability seems intuitive and simple. One said they're a bit cynical, but the ability to monetize access to the data for commercial users who want to use their own development processes is also appealing. And in a conversation I had recently with smaller archives in British Columbia, they actually said, yes, they're really interested in this because what they're finding is they're making all of their digitized records available on the open web. And then AI bots are coming in and hoovering all of that up. And they would like to use Clio-X to make information about their data available on the open web and maybe some examples, but then divert users to using Clio-X and potentially if they're wanting to do large projects, like it would enable them to charge a small amount to recoup costs for the processing that goes into making all of these records available. So they're really liking that monetization feature potentially. Others say, retaining ownership is really important. They like that. Digital money, some people, they like it, but they're confused about it. They like that there's research underpinning the work that we're doing. And others have said that they like the way that the process works. And also like a safe place to utilize AI capabilities. And the other thing that we're planning on doing is making sure that we vet the AI. We're doing security analysis of the AI. We're preparing model cards about the AI. So it's very transparent, what the AI has trained on, how it functions, who's designed it, all of these things that are needed for ethical AI. They like the display of the outputs. The 3 personas made sense to archivists, and they found it generally to seem like it's user-friendly. So we're getting good feedback. Obviously, we have many things that we need to work on still. We've only just launched this in June of this year. We're just discussing onboarding our first partners. These partners are, very early stage, kind of helping us refine the platform before we make it widely available. And we do have on our immediate technical roadmap improvements to the chatbot in terms of how it functions efficiently, because we're very aware we don't want to just kind of default to like, oh, let's just throw a 20B model and a whole bunch of GPUs at it. Let's try and refine our technique, hone the development of our R.E.G.I.I.M.E.N.T.O and our knowledge base so that we can use lightweight, more efficient AI models. So we're working on that. We're also working on the accuracy of the output. And as I said, looking at multimodal, multilingual. We want also easier onboarding. It's getting pretty easy, but you still have to set up a Web3 wallet. That can be confusing for archivists who haven't got any exposure to the Web3 world. So we're trying to make it really like you don't have to know anything about Web3. And we also have heard that it would be really useful to have techniques like sound recording transcription available for our researchers. So we're looking at that. Those are some of the things we're looking at next. So with that, I'm going to end my presentation. So I'll come back out here. I'm going to allow, and I'm going to end the sharing for now. So if I stop sharing, I think I can figure out how to do that. Oops. Yeah. So okay. You can see me still, but my presentation is over, and now I can just answer questions if you like, if there's still time.
Thank you. Thank you. So we have one question. Therefore, how can this technology be adapted to archival principles, such as classification, evaluation, elimination of duplicates and other information?
Well, I mean, the whole idea is that the platform should be governed and developed by archivists. So if there are so when we developed it, we're of course archivists. So we're always thinking about archival principles and, things like authenticity and how can we guarantee that, and the importance of integrity. So if there are particular issues, archival issues that need to be addressed and built into the platform, because the platform is meant to be governed collectively by archivists, we do feel that there's much scope to address those issues. Now, classification of records is what we would call a use case. Let's say I want to use the Clio-X to classify, say, images like we had in the previous presentation. Well, that we can then add AI into the platform that could be made available, maybe as a software as a service, and then it would be set up so that you could load up your images from your database of your collection of images, and the image classifier AI could come together with your images in a trusted execution repository to classify your images. And then the researcher would get an output, which would be, maybe some kind of visualization of the image classification, such as what we saw in the previous presentation. If we want to classify, for example, according to function, archival function, again, you can create an AI algorithm that runs over your Enron emails, for example, or your email collection, that classifies your documents according to function. In fact, one of my previous PhD students, Nathaniel Payne, developed a technique for functional classification of archival documents based on the principles of archival diplomatics. And he created a machine learning algorithm that does that. So his machine learning algorithm could be deployed on Clio-X. We haven't done that yet because we're working with use cases that we determined to be the ones of most interest initially. But we're open to working with all kinds of archival use cases. And of course, everything has to be done according to archival principles.
Thank you. There is more questions. The other one.
Okay, and this, in what ways can decentralized governance strengthen ethical accountability and trust between archives and researchers? Yeah, I think that really this is very, very important, because right now we have a model of AI governance which is very removed from the communities that the AI is going to be applied to, and also who's going to use the AI and who's going to provide the data for the AI. And so when we create decentralized communities, we create the opportunity for community governance of AI safety. So then the people that we're working with, or the data that we're working with, is not sort of like some abstract data point, but actually part of our community. So I think that really kind of emphasizes that the idea of human dignity, because if okay, here's AI algorithm, it's designed specifically for archives. Archivists will think about, the concerns of privacy protection, who is mentioned in the archives, things like in the context of Canada, for example, Indigenous rights and how Indigenous people are portrayed. So we can become more concerned about bias potentially, and how people might be disadvantaged by the way that the AI computes over the data. And we can design AI and processes for deploying the AI that in our context are considered to be fair and human-centered and ethical. Similarly with the environment, and the environment is very important to us. And so if we have issues that are particularly important, then we can say, well, this is important. And, we might then say, well, the access controllers we use have to show us that they're energy efficient, or that they're using green energy, or that they reduce their water consumption. So by decentralizing and creating a community governance framework, we can embed our community values. We don't have to agree to the one-way values that we get when we are interacting with ChatGPT. It can be very much, a mutually supportive and agreed set of values.
Okay. Another one?
How does it ensure the ethical use of AI in archival data mining while preserving authenticity, provenance, and equitable access to information? Okay, so that's a very broad question, but let me just break it down. So authenticity, it is protecting by creating an NFT of the location of the data, and it knows that that data there is coming from an archives. The originator of that data is the archives, and so there's a trust that's placed in the archives that the data in the archives that's being made available at that location is already authentic. So then what we do is we turn the location into an NFT, and that NFT is registered to a blockchain. So then we know that, the data that's available at that particular location, that NFT represents, we know that it has integrity, because that's what the blockchain does. It makes sure that what is made available isn't altered or changed. So as long as it comes in authentic, which we assume it would be authentic coming from a bona fide archives, because the world trusts us to be providing authentic records. Of course, it is becoming a challenge for us because it's always been the case that archives, sometimes forged documents come into the archives. But we know that the documents that are being made are coming authentically from, the archives, and there's a large trust in our institutions. We are challenged these days by the potential entry into our institution of AI-generated deepfakes. So that's an issue that we potentially could address, again, by applying AI. So, for example, if an archivist wanted to check, an ingest of archival documents coming in, we might be able to provide AI software that does a check of the authenticity, the trustworthiness of those records, and does a kind of a measure and flags anything that looks like it could have some issues. So there are ways that we can use AI in this platform to even strengthen the authenticity, but definitely once the location is made available, that NFT cannot be meddled with, and we can do service credential checks to make sure that the if somebody's claiming to provide this data, that we can check it by checking back to the blockchain to say, no, that is not an authentic NFT, or yes, that is an authentic NFT. So these are some of the ways that we can protect authenticity. Provenance. So with the blockchain also comes the ability to trace every smart contract execution on the blockchain, every transaction on the blockchain. So every time an NFT is created, anytime an AI is uploaded, anytime an AI and data, a compute job is performed, any payment that is made, all of that gets tracked and logged on the blockchain. And so it is possible, therefore, to create a chain of custody and also a chain of, a processing chain, which is what, now archivists are starting to talk about the need to create paradata that talks about how the data is created, how, the algorithms that interact with the data, the outputs of the data. All of this can be tracked through Clio-X because it's executing on a blockchain, and all of those transactions get recorded on the blockchain. That's very helpful. So if we need to figure out, what data contributed, let's say we're training an AI model using Clio-X, we can very transparently see which data contributed to the training of that model, because we will see what data sets the person who was training their model, what what data sets they uploaded into from Clio-X to train their model. So it can all be tracked very transparently. In terms of equitable access, I would say that's that's a very broad question. I think how equity is really achieved, it's achieved primarily because it's decentralized. The compute infrastructure and the AI is decentralized. So it doesn't matter if I'm in the National Archives of Cameroon and I can't build these AI algorithms or set up this AI infrastructure myself. I can still access it through Clio-X. That increases global equity, because then archives from all over the world that might not be able to access these tools can access the tools. And then through collective governance, as I mentioned, we can attend to issues of equity. We can make sure that we prevent bias in our algorithms, that we look at how the data sources and the outcome to protect against bias, and how groups are represented. And finally, like in terms of indigenous rights and rights of protected groups, a lot of their data, when it's put up on the open web, is just stolen from them. Images of, that are indigenous images, culturally significant images, are just stolen and consumed by AI bots. Clio-X prevents that, because you can't get at that data unless you agree to the terms and conditions, and you wouldn't be allowed to access the platform if you are going to be like one of those cultural heritage stealing AI bots.
Yeah. Oops.
Okay. The Brazilian government doesn't have classified GovNet, SpearNet, and operate under national security protocols. Does Clio-X possess the accreditation to manage classified data? Not yet. So, as I say, like we are building privacy preserving infrastructure, but we would have to work with classified data. First of all, we want to make sure that all of the technical components were located in Brazil. We would have to harden the infrastructure. We would have to meet, your state and, national security requirements. So we're not ready to handle classified data yet that is considered, highly sensitive classified data. So we can handle some data that has maybe some personally identifiable information in it. We can handle that quite comfortably, but I would not even accept that kind of data right now into Clio-X until we have had a privacy impact assessment and a security assessment done, for the platform as a whole. And that is something, because we're not fully operational yet, and we're still, in this kind of experimental stage, we're only experimenting with data sets like the Enron data sets that simulate classified information. But your open data, any open data on the archives, data that would you normally make available through the open web, that we can handle right now, and we're happy to accept it in Clio-X.
Another question.
Cost for licensing or operational costs per user per year, total deployment to implement and use Clio-X. So at this point, so the idea is that it should be very decentralized. So so that is a bit difficult to answer, because because the platform, it will depend on what access provider you choose. So if you need CPUs and you don't need GPUs, CPUs are cheaper than GPUs. It would depend on how much, how many transactions you're running on Clio-X. And so right now I can say the cost is very low. You can see like 0.1 of a euro every time you run a compute job for the platform as a whole. So it doesn't really cost that much, but it's going to depend on the volume of usage and the type of infrastructure that you're requesting. That's the basic denominator. Once we get this is why we want people to join and start using Clio-X, because this will help. We're going to offer everything for free for a while, because then we get a better sense of like, okay, how are people using it? What is it costing them? And then we can provide more detailed information about that. But, if you're offering your data for free, there's an opportunity to earn that back as well. No, it's not in production yet in any archives. We're still in pre-production mode. We are at technology readiness level between 4 and 5, and we are looking to actually work with some archives to bring Clio-X into production in a kind of a preliminary way. So not fully commercialized production, but just like pre-commercial production. So as I say, we can prove it out. We can, check the costs, and that way we can put it fully into production for all archives around the world. Clio-X seems perfect for community archives and small archives. Yes, I would agree with you. I think that it is perfect for community archives that cannot afford to stand up. Like, they couldn't afford the cost of running their own access provider, which, can cost you $7,500 per year just to have access to 4 GPUs. Never mind, the computing costs of actually using those GPUs. So, and they wouldn't want to do that, and they wouldn't have the technical expertise for the AI. So absolutely, it is perfect for them. At the same time, it's the big national archives that will have the technical expertise to contribute AI algorithms and to help support the smaller community archives. So it is really about all of us supporting each other collectively.
Okay.
I hope so. I really hope so. So we really hope that, by learning about us, you can join the community. Please feel free to reach out to me if you are interested in using Clio-X, and because this is how we will be able to study it and make it available. Yeah, we hope that also we can make it will help with traceability, as we say, gathering paradata about archives, but also one of the other software as a services that we are in discussion with a partner that handles decentralized laboratories is, can we provide emulation, software emulation for digital preservation? So that's one of the capabilities that we do plan to introduce. It's a longer term roadmap that I gave you, like the immediate roadmap, but in the longer term, we also want to be able to do this. Okay, obrigado. Okay. So if there are no more questions, then I just say, yeah, obrigado, and thank you for your time and attention, and Claudio for the opportunity to present today, and looking forward to hearing from anyone who wants to follow up about this.
Thank you. Thank you, Professor Lemieux. So I will talk a little about in Portuguese. Então, muito obrigado, professora Lemieux. Agradeço também a audiência. Estaremos aqui novamente amanhã, no mesmo horário, às 18 horas. Se alguém tem mais algum questionamento, alguma dúvida, pode passar, para a nossa equipe, que depois nós entraremos em contato com os palestrantes, e traremos as respostas. Então, novamente, muito obrigado, uma boa noite para todos e até amanhã.